question number 6. We've got to find the roots of the equation and give the answers to one decimal place. So that suggests we should use the quadratic equation. X is negative b plus or minus root b squared minus 4ac all divided by 2a. So a is equal to 2, b equals 4, and c equals negative 9. So substituting these into here, we'll be able to work out what the roots are. So it's negative 4 plus or minus the square root of b squared, so that'll be 4 squared minus 4 times 2 times negative 9, all divided by 2 times 2. So tidy all this up, especially this bit. So 4 squared is 16. You've got negative 4 times 2 is negative 8. Negative 8 times negative 9 is positive 72, so plus 72, all divided by 4. Again, make sure we tidy up this bit called the discriminant. So it's negative 4 plus or minus root 88 over 4. So we're going to have two answers, one where we're doing negative 4 add root 88 over 4, and one we're subtracting. If we add, first of all, we get x equals 1.345, which is just 1.3, and that's to one decimal place. And if we subtract, we get x equals negative 3.345, etc. So negative 3.3 to one decimal place. So our two roots are 1.3 and negative 3.3. Next, we've got to find the volume of the larger bottle. Now I'm going to do this twice, once where I'm going to do 9 over 6 and once I'm doing 6 over 9. So my linear scale factor is 9 over 6. My volume scale factor is a linear scale factor cubed. So it's 9 over 6 cubed. So if I know the volume of this is 30, I'm going to use that and the linear scale factor cubed, that's the 9 over 6 cubed, to work out the volume of the large one. So it's 30 times 9 over 6 cubed, and that comes to 101.25 millilitres. Now you may have done 6 over 9 instead, and said that your linear scale factor is 6 over 9. Therefore your volume scale factor would be 6 over 9 cubed, in which case we would have to do 30 divided by 6 over 9 cubed, which would give us the 101.25 millilitres. Either way, you know that this answer has to be bigger than 30 because it's got a larger volume than 30. Question 8, determine the nature of the roots of the equation. Now, in order to do that, we need to have it in the form something's x squared and something x plus the constant. So we can multiply at the bracket here first. So that is just x minus 2 gives us x squared minus 2x plus 4. So that's x squared minus 4x plus 4. So that's just this little bit here multiplied out. So we'll have x squared minus 4x plus 4 minus 5x equals 0, tidying it up. X squared minus 9x plus 4 is equal to 0. Now we don't need to find the roots, just the nature of the roots. So we want to find out what the discriminant is equal to. So we don't need to use the full quadratic equation, just the discriminant part of it, the b squared minus 4ac. So for b squared minus 4ac, a is equal to 1, b is negative 9, and c is equal to 4. So if we substitute those in, we get 81 minus 16, which is 65. Now that's a positive value, which means if we were to substitute it into here, you'd end up with two roots. You get plus root 65 and minus root 65. So we can therefore say b squared minus 4ac is greater than 0. Therefore, there are two real distinct roots. If it had come out as a negative number, there would be no real roots, and if it was 0, there would be, you can either say one root or two equal roots, and it'd still be real.